2 cosine squared x equals cosine x, and we want to solve for x. So notice that we have cosine on both sides of the equation, so I'm going to move them all to be to the same side. And I can do that by subtracting a cosine x from each side. And then because I have two terms that both have a cosine in them, I'm going to factor that cosine out. And that will leave 2 cosine x minus 1 equals 0. And then if you'll remember from algebra, if you have two things that multiplied together equal 0, one of them has to be 0. So that means cosine x equals 0, or 2 cosine x minus 1 equals 0. If cosine x equals 0, then we can go back and think about our cosine graph. Where is the cosine equal to 0? And cosine is equal to 0 at pi over 2, and also at 3 pi over 2. But because we're not restricting our domain, then we would go back and add plus 2n pi to both of those answers, where we know n is an integer. And that would take care of all the coterminal angles that are coterminal to pi over 2 and 3 pi over 2. For the other half of the equation, 2 cosine x minus 1 equals 0. That means that 2 cosine x is equal to 1, and the cosine of x is equal to 1/2. So thinking of our special right triangles, if the cosine, which is adjacent over hypotenuse, is 1/2, the third side of the triangle would be square root of 3, and this matches up to a 60-degree angle. 60 degrees in radians is equal to pi over 3. So cosine is positive in the first quadrant, and that would give me pi over 3. And then cosine is also positive in the fourth quadrant, which would give me 2 pi minus pi over 3, which, if we get a common denominator, would be equal to 5 pi over 3. And so then, to take into account all the coterminal angles, we would go back and add plus 2n pi to the answers that we came up with, and there would be the solutions to this equation. Going back to the first part of the equation, pi over 2 and 3 pi over 2 are pi units apart. So we could also write this part of the equation as pi over 2 plus n pi, and that would take care of the second answer, and we wouldn't have to include it.